it doesn't work, everything falls apart on you. So hi, I'm Borko. I'm going to talk primarily today about a research project that I've been involved with for quite a number of years now, developing a model of professional development and then trying to bringing it into a school system. And try to talk a little bit more generally about some of the things we're learning that will hopefully apply to other programs. And if something is confusing or if you want to ask questions, please feel free to ask questions. So I'm just going to really quickly try to connect it to the Common Core because we don't do anything these days without trying to connect it to the Common Core. Just to say that the Common Core, one of the things that's been really nice about it is the push for the support of professional development for teachers. And so now, okay, this still isn't working really well, but we'll just, okay. So one of the things that the Common Core says is that educators must be given resources, tools, and time, instructional materials, assessments, and policies to support them. And basically one of the things that means is that teachers have to get support, and teachers have to get resources, and teachers have to get professional development. So I had the opportunity to be at a meeting that was supported by a joint task force that was representing just about all of the major mathematical and math ed associations. And what our charge was to develop a set of recommendations on policy and practice for professional development. And one of the things that came out of it was so this is the task force goals, and as you can see, there were 6 goals, and 2 of them really focused on the process of professional development, developing capacity at all levels to effectively implement the College Core, and preparing and supporting math educators. So the work that I'm doing predates the Common Core, but it's been really nice to see that it gets kind of an added boost by the Common Core. And I don't think we really need that. Okay, so the project is the original professional development that we developed is called the problem-solving cycle. The project that we're working on now is called implementing the project problem-solving cycle. I'm going to first talk about the model itself and then talk about how we worked with the school district to scale it up and to learn a little bit about what it takes for math leaders in schools to actually do professional development. What does it mean for a teacher to become essentially a teacher educator or a professional development leader? The 2 colleagues who I work with on this project, Jennifer Jacob, who's at CU Boulder still, and Karen Kellner, who's now at Hunter College. When we started this project, it was all based in Colorado. And we've had numerous graduate students work with us on various phases of the project, first in Colorado, and now we've got a team actually at Hunter and a team at Stanford who are working on analyzing the data that we'll never be through analyzing. So the problem-solving cycle is a series of interconnected workshops. It's focused on knowledge of math for teaching. Basically, it's around problem-based teaching. So how do teachers learn to teach with problems? And we focus on both knowledge of mathematics, specialized content knowledge, also students' mathematical reasoning and instructional practices. So if you think of the work on mathematical knowledge for teaching that Deborah Ball, Heather Hill, Hyde Bass, and colleagues have been working on for a number of years, it's really the SCK, specialized content knowledge, knowledge of content in students, and knowledge of content in teachers. So we try to work on all 3 of those, which is something that's maybe a bit unique about our program or different from a lot of other programs. This is a graphic representation of the model, and I'll talk about each of the steps in a little bit more detail. But the first thing that happened is that teachers work the mathematical problem together. We've been working in middle schools, and because we want everyone to have a shared experience, we pick problems that will work across the grade levels in middle school. So what that means is that they have to be problems that can be solved with a number of different strategies, some of them requiring more abstract reasoning, and some of the strategies more concrete reasoning, and that usually there are problems that can be either extended or scaffolded in a way that makes them more accessible. Everybody teaches the problem then and videotapes it, and then the bulk of the professional development is around bringing the videos back to the professional development and having teachers look really closely at student thinking and look really closely at instructional practices. So one of the reasons that this has worked for us in school districts and has worked with us for multiple grade levels is we're only asking the teachers to fit one problem a semester into their curriculum. And then the rest of the professional development is based on the lessons that they taught. Yeah?
What's the difference between the leftmost box and the bottom one?
So that's a really good question. When we started out, we had this notion that we could really separate out instructional practices and student thinking. And we talked about in our heads that first teachers would look at student thinking and they would analyze small group instruction, and then we would work on instructional practices. In fact, of course, you can't really do that. And so what that means is that the emphasis first is on student thinking, and the emphasis second is on instructional practices. Even that's a little bit fuzzier these days. What I can talk about when I talk about how we've had to adapt it to work to scale it up within a school district. In fact, this whole notion of 3 workshops built around the same problem gets shifted around based on the priorities of schools. So the first box, solve problem and develop lesson plans, we originally thought of that as 1 workshop, but given the constraints of public schools and the fact that if you're lucky you can get an hour, we now recommend that teachers spend an hour working the problem together, and then they spend another chunk of time, probably at a different time, actually working together on planning lessons around the problem. So now these are from videos that were taken in the original development of the problem-solving cycle. And what you see in your left is a group of teachers solving a problem. It's the painted cube problem, which is probably familiar to some of you. You know, there's a number of classic rich mathematical problems that we see over and over again. So in this one, you have a cube that's painted on the outside, and the question is how many of the little cubes that it's made up of have 1 face painted, 2 faces painted, 3 faces painted, or no face painted. And the way that the problem is expandable or extendable is that you can start with a 2x2 and go all the way up to an n by n problem. So in the first one you see the teacher solving the problem, and in the second one you see one of the teachers who's taken the problem into his classroom. And this was a particularly interesting teacher because he never worked with small groups before. And he's one of the teachers that actually made some really substantial changes in his teaching over the course of the couple of years working with us. So now you're going to see sort of the ideal of what it looks like to have an ideal what working on student reasoning looks like and working on instructional practices. So what you see here is a small group of students working on the problem, and the clip was about 5 minutes long, and it was a really interesting discussion where one of the boys was trying to explain to the others what exactly was going on, and he was explaining it really fast with a lot of the ideas in his head but not really being articulated, and the pushback that the other boys gave him. And then what you see here is what actually, and he had a unique way of solving the problem. What you see here is something that often happened in the group, which is when the teachers watched the video, they actually then went back and said, oh, none of us tried to solve the problem that way, and they went back and did some more work on the mathematics of the problem, and that's what you see on that whiteboard, and you see all of the teachers kind of working on the problem. So that was actually, that's the kind of conversations that often got engendered when you had teachers watch small groups student thinking. And what you see here is a workshop that was focused more on instructional practices. That is an example of student work. The teacher had gone up to the student and asked her to explain her work. She also this is a different problem. It's actually the window washing problem, which is figuring out the cost of washing windows on a skyscraper when the cost goes up every floor. So this girl had a different way of solving it than was in the teacher's head. She was solving it, I think she was solving it one window at a time. Like she was solving it one window at a time and then multiplying rather than solving the floor at a time. And he, rather than asking her what was in her head, he was using what's often called the Socratic method. So he was trying to push her to understand it the way he was understanding it. This is a video that we used actually at the very end of our work with this group of teachers. It's the kind of video that's sometimes pretty risky for teachers. And he ended up, and then there was a long discussion about the video where they were talking about how she was solving the problem, what the impact was of the questions he asked, other kinds of questions that he might have asked. So a rich discussion on what do you do when students are solving a problem and you walk up to them and you don't quite understand what they're doing. So that was the instructional practice. Questions about that? So the problem-solving cycle is based on a number of core principles. Again, everyone teaches the problem so that they have a common mathematical experience to come back to when they're looking at the videos. The professional development is situated in their instruction through artifacts of practice, which is usually video. We also sometimes actually bring in student work or work that groups of students have done together and look at the student work. Central role of community. The PD is long-term and ongoing, and those two are really closely related because as the community develops, you can push a little bit harder on the conversations in the professional development. You can look at riskier situations. And that it's adaptive to the participants' needs and priorities. So my colleague, Karen Kellner, and another colleague, Nanette Sego, developed this notion of a continuum of video-based professional development from highly adaptive to highly specified. Nanette Sego is a person who does commercially available video cases for professional development. And so the work that she does, the current work the project she's developing now, or we're developing, is learning and teaching geometry. So that's very highly specified. There's a learning trajectory of geometry. There's a very explicit set of problems that she bases the video on. Then she has teachers literally around the country work with their students on the problem, and we have about, I think, over 100 hours of video from which we're selecting. There's probably about an hour's worth of video that is used in the professional development model. So it's highly specified, the video is really good quality, and the videos fit along this progression. So the project chose the content, the project chose the video, the project determines the resources, and they're not generated organically in the program. The advantages are you get really high quality video and you get to really control the curriculum of the professional development. On the other side are highly adaptive. The most highly adaptive is that we use as an example is Miriam Sharon's work with video clubs, which is work where the teachers actually basically choose video that they want to bring into these video clubs, and the conversations revolve around those videos. So ours is closer to the highly adaptive side in that the facilitators do make the decisions taking into account the local context. So in this particular case, we talked to the teachers and they wanted to work on algebraic reasoning. So that was the mathematical focus. That was decided in advance. We also chose the aspects of student thinking and instructional practices, although we worked with the teachers, and also it was dependent a little bit on the video that was available. And there's also a lot of flexibility in the structure of the workshops, so that we can take into account the needs of the teachers and the districts. And the needs of the teachers and the districts are both substantive needs and also structural needs in terms of what's going to fit in. Are we still good? Then we did a number of different research studies on this project. The professional development, we started with the summer mathematics course. That wasn't necessarily part of the model, but that was something that was offered through the university, and out of it grew teachers' interest in the professional development. So we then worked with teachers for 2 years in a set of workshops. We ran through 3 iterations of the problem-solving cycle. In year 1, we had 8 middle school teachers working with us. In year 2, one of them dropped out because she actually wasn't teaching that year. And 3 new people came on board, and they were all paired with teachers at one of the other schools. So for this one, we were working with teachers at a number of different schools who we brought together for these workshops. And basically, we videotaped everything you could think about videotaping. So we videotaped our professional development, we videotaped their classroom lessons, we interviewed the teachers, we interviewed the facilitators who actually were us. So Karen was actually running the facilitation for a good part of the time, and then we had some graduate students taking on those responsibilities, and we had the written reflections of the teachers. So one of the studies that we did was a study of video as a tool for teacher learning, and what we were really interested in was what's the nature of discussions around video in the workshops, and do those discussions change over time, and what's the role of the facilitator in guiding those discussions. So you can imagine that we had a huge amount of data. So we made some decisions about where we were going to land in terms of analyzing, and we decided that we were going to analyze whole group discussions around video within the professional development, and that we were going to start with, we were just going to look at the first cycle and the last cycle, since what we were interested in is change. And we coded the video in 2-minute segments. So we would watch 2 minutes and then ask, when did it take place? In other words, was it before watching video, during video watching, or after video watching? Who was doing the talking in that 2-minute section? What were they talking about? And what was the content of the conversation? And so one of the things that we noticed was, in terms of overall changes, the conversations were longer, and there was less setup time to the conversations, so the teachers would launch into the discussions. That example you saw with the mathematics on the whiteboard in the background, that conversation, which was about the mathematics, lasted a good half hour. Whereas conversations at the beginning would maybe be 10 minutes. So the conversations became longer, they became richer. In terms of student reasoning, they became more focused on the mathematics and a richer, more sophisticated exploration of the mathematics. So at the beginning, you would see teachers focusing more on group dynamics and who's participating and who's not. Those things are all important, but we really wanted them to look closely at the mathematical reasoning of the students. So that was the kind of change that we were hoping for. With instructional practices, there was less just describing what they saw and more giving suggestions. And one of the things that we noticed is that the professional development leaders, as they started to sort of develop their own expertise, they offered more guiding questions, and the questions really helped to focus the direction of the discussions. So a couple of things that we took away from that were the role of the facilitator in guiding discussions, and we developed a facilitator guide based on this project that we've then taken into our other work, and one of the things that we built into it that was not originally where we started was the role of the facilitator in guiding the discussions, both in setting up watching the video and then in facilitating the conversations around video. And I'll talk more about that because we've learned a lot about that in our work trying to prepare other people to do this work. And the second is the importance of a supportive community. And supportive community was a real key factor, and we were very intentional about the notion of a supportive community because we knew that a number of other people who had worked with video found teachers very reticent to share their own video and to talk about their own videos. So we were very conscious of trying to build a supportive community to move into watching video slowly, starting again with video that seemed less risky, and we really saw the advantages of that over the course of the 2 years. Yeah?
Sorry, Howard. I don't quite understand. What is this supportive community? Is the same group of teacher and facilitator? Who
Yes. So it's the community of teachers who are working together. So for example, in that, in the video that, in the video where I showed student work, and then I said that the teacher had really not liked the way that he was working with that student, the community of teachers in that conversation, the first thing that they said to him, I remember this, one of them said to him, "Now, wait a second, you're being awfully hard on yourself. You know, you were acting in the moment. I'm sure I would have reacted the same way." So they were very supportive of him and encouraging him to, to think differently and to take a more positive spin on it, rather than some of what you read in the literature about teachers being very critical. And the first thing that they did, and in fact, this is something that we pay a lot of attention to in our work. Miriam Sheeran has a wonderful, like 2 or 3 page article about about working with video with teachers. And Jim Stigler and Jim Hebert have an article that I call the Teacher as Heroes article. And it's talking about how it's really risky to put your video out for other people to watch. And it's really important when you're watching the video of other people that you be respectful of and appreciative of what they're doing.
Did you bring along some clips, not to be snoopy with the pictures of the people that are concerned about, but did you bring along some clips to show us some examples of
I was thinking about that and I didn't. Yeah, unfortunately they're not on this computer.
Oh, okay.
Actually, when we're doing question and answer, I can see if I might have some video from the new project. I think I do have some of that video. In fact, I'm pretty sure I do. It'll just take me a while to organize for it. So the next thing, and part of that is with human subjects that became really hard, and also now the technology is, it's much easier to watch video. It didn't used to be that easy to watch video. So the other thing that we tried to look at was changes in teachers' instructional practice. And we used a coding system. The coding system we used was the MQI, the Mathematical Quality of Instruction, which some of you may be familiar with. It was developed by Deborah Ball and Heather Hill and colleagues. It's actually one of the instruments that's being used now in the Gates study, where they're trying to develop measures of effective practice that can be used nationwide. We used a very early version of it. The versions now look a lot different. And we modified it a bit to fit the problem-solving cycle, the goals, and the design. And we worked closely with Heather Hill, one of the developers, when we were doing that. And I'm just going to show you some of the findings from just one of the cases. So this is Ken. He's actually the teacher who we saw in that first still. The bars on the leftmost side are from the lessons he taught before the problem-solving cycle. The one in the middle is the problem-solving cycle, and then the one on the right is after. So what are some things that you notice?
There's a lot less review.
There's a lot less review. And if you think about supervising student teachers and what the American classroom too often looks like, the first 20, 30, 40 minutes of a class might be going over homework and review. So that was a pretty consistent pattern that we saw with the teachers, is that they spent a lot less time doing that.
They began closing the lesson.
So at the beginning, there was no closure to lessons. Basically, that was not unique to him. And so what we saw is for the PSC lesson, there was a lot more time spent on closure. And the post-PSC lessons, not a little bit more review time, a little bit less closure time than in the PSC lessons, but still more than the pre ones. So one of the people who was meeting with me this morning said, do you see that this result generalizes? Like, do they just do this with PSC lesson, or does it sort of bleed into their other lessons? And the work we're doing now, analyzing the scalable, the scaled up project, we're better able to analyze those data and really answer that question. And the answer looks like yes and. So the teaching practice changes. It changes in complex ways. It changes in slow ways. But we do see changes that cut across their instruction, not just for the PSC lessons. So this is the use of mathematical representations. Again, what do you notice here?
Looks like you can't use your problem solving without having a representative and using this and making links and integrating it in the practice.
Well, you can. I mean, kids can solve almost any problem without using representations, without using manipulatives, without thinking about graphs and tables, and try to go right to equations and systems of equations or expressions. We push hard in the problem-solving cycle that teachers not have students work that way. That teachers have students think about multiple ways of representing, that they think about tables, graphs, explaining in words, using manipulatives, and so what we start to see is, yes, you do see more of that in the PSC lessons. Is there a hand? Yeah.
Brad, do you have one?
I'm not sure what select and deploy, I'm not sure what those mean.
So select representation is, does the teacher select different representations to use? So one of it is in their planning, are they actually choosing representations? And then the other is, are they actually using the representations in their teaching or having students work with the representations?
Okay.
So sometimes they intend to, and then it just doesn't get worked into the lesson.
Could you clarify what the vertical axis is? 0 to 100, is that minutes, occurrences?
It's
or
percent of those 2-minute segments.
percent of the 2 minutes?
Yeah, sorry. So in what percent of the 2-minute segments did we see all of these?
So are all the classes exactly the same in terms of their class time? So if I'm watching a teacher do something in segments, like some teachers teach for 60 minutes and some teach for 90 minutes. Or did you have this control so that it was all occurring within a 20-minute
We
period?
didn't have a control, but there were no block classes. I mean, the teachers, none of the teachers in this one were teaching block classes. So, so this was a study that was a small group of teachers. They were volunteers. They were in couple of school districts. that were all using, well, they weren't all using the same textbook, but they look very similar in some ways. The work that I'm doing now in San Francisco, for example, this would look very different just because some of them are on a block schedule, some of them would choose to work the problem over 2 days or 3 days. So what we're finding, so we can't do these neat kinds of analyses
Right, no.
now that we could do then.
Can you account for why it decreased on the last two?
No.
33 to 13 and 26 to 14, why it's less than what it was before?
No.
All right.
No, and this is so, so this is not something that we're going to, use to say we've got statistically significant differences. This is one case study that, trying to unpack and explain what happens in classrooms is never really neat. And we don't have a huge sample of lessons. So and in fact, we always, we talked a lot about, so do we show confusing data with real results? Of course we do, because that's the reality of classrooms. We could go back and do a detailed analysis of each one of these lessons and try to unpack what happened, but that wasn't really what we were interested in. We were interested in sort of on the things that we're really highlighting. Do we see some changes happening? And we see more changes in the PSC lessons than we do in the lessons after the PSC, but we do see some changes that are things that we were working toward. And the other thing we learned here, and again, you'll see this even more in the next phase, is using multiple representations and especially making links across multiple representations and trying to look at the relationships of them is difficult for teachers. So it's not surprising that we see that happening less, and actually that decline isn't that surprising. And that could be due to just the lessons that we happen to observe.
Not being a mathematician, what kind of representations are we talking about here? These are geometric or figures or?
So this is where a video would have helped.
Yeah.
So in the painted cube example,
Right.
You saw people working with the cubes.
Mm-hmm.
So one of the representations is the manipulatives, is the cubes. The other representation that a lot of people use on that is a table. So they'll have a table with they'll have a table with a 2 by 2 by 2 cube, a 3 cube, a 4 cube, a 5 cube, and then you'll see the columns for 0 faces, 1 face, 2 faces, 3 faces, and they'll start to try to look for patterns in the table. That's good. And then so it turns out if you can picture a cube, all cubes have the same number of corners, right? So all cubes are going to have the same number of individual cubes with 3 faces painted, 8. And so for students to start to see the pattern of, oh yeah, there's only 8 corners to every cube. And so of course the number in that column is not going to change, would be the kind of thing, that's like looking across and making links between representations.
And so some of these must be occurring in tandem. So if you're selecting and deploying a representation, it'd be the number of occurrences within a 2-minute coding cycle.
Mm-hmm.
So I'm watching for 2 minutes and I see them select and deploy a representation, they could do it 10 times. So I get 10 in each column. 10 for select and 10 for deploy. I'm not clear. I will talk to you afterwards about the coding of this.
Just 2
Get one for that
You
segment,
won.
because it's a 2-minute segment.
Shouldn't it all add up to 100 then? So like if you have this segment, you're going to have this total instead of having fewer, or they're spending more time on things which causes for less occurrence of coding. So if I'm coding something and it happens quickly, I'm going to get more of it. But if I'm coding something in a set period of time, and it doesn't happen quickly, I won't get as much. Is that what that's saying? By the
It's a binary there, right? Yes or no, we saw it, we didn't see it in that
Yeah, it's
2-minute
just,
clip.
so way that this coding scheme works is you take a 2-minute segment, they're actually now using 7.5-minute segments in the MQI, and you say, did this activity happen at least, I mean, in the 2-minute segments, did it happen at least for half of the time?
Okay.
And these are just You know, this is kind of the coding rules that came with the instrument, yeah.
So 19 means 19% of the time this was going on beforehand. 26% of the time it was going on during PD, 14% of the time it was going on after.
19% of the
segments.
segments, right.
19%
Of the segments, not of the time.
Yeah, I didn't use time the right way.
So if there's a 60-minute class, it would be 30 segments.
Wait, what are you saying, Ron?
If there's a 60-minute class, it would be 30 segments. So 19% of those 30 segments
Right,
had making links prior to the,
right.
okay.
So this is Ken, the teacher, and what he said about his experience. And one of the things that was really neat is that the year after the project, he won Teacher of the Year award. So he was one of the state Teacher of the Year awards. So that was neat. So, other questions about that first phase? So in the next phase of the project, again, this is the efficacy study, which is, and so the question is the model effective in improving instructional practices and student learning? So now we do have enough data to actually do some statistical analyses of that. Again, before we weren't even claiming to do that. But we felt like we learned enough, and NSF felt like we learned enough to be willing to support us to do this next phase. So is it effective in improving instructional practices and student learning? Is it scalable? Can we take it to a different context? And is it sustainable? Can it be enacted by different instructional leaders? And that last question was really one of the main ones that we were interested in. You know, one of the limitations of most professional development studies that are out there is they're what's often called boutique professional development. So one person develops this model, and that person is really quite good at using this model to work with teachers, but that's not very sustainable if the model can't be shared with other people and other people can't wait to use it. So that was our main question. So we have one school district, 5 teacher leaders in 3 middle schools in the first year of it, then 8 teachers in 6 schools in the second year. That particular school system wanted us to work on ratio and proportion, so we worked on ratio and proportion. We start with the summer academy and do 2 cycles, and I'll show you a little bit more what that looks like. And so we revised the intervention and research design to account for changes in participants. The model that we developed was supposed to have half the schools it was supposed to have volunteer schools in the district, but they thought they could get us over half the schools, and they would stay with us for 2 years. That didn't happen. So we lost one school. I know, people are laughing. Of course it didn't happen. Why would we think it would happen? We lost one school after the summer leadership, and then because of a change of administrators. We lost another school between year 1 and 2 because of a change in administrators, and so only 3 of the teachers from year 1 actually went into year 2. So of the 8 facilitators in year 2, only 2 of the schools were the same, and 3 of the facilitators were the same. So where we thought the second summer would be building on the experience of the first summer, it was building on the experience for 3 people, and it was building on our experience, and it was 5 new people.
Seems like it's a real world problem, is looking at ratio and proportion of teachers.
Why get that better?
Right.
Yes, well, yeah, I mean, and it's, and it becomes difficult when some of the analyses, want to do, you can't really do, but. I mean, I think that the other thing is that at some point you make a decision. I made a decision anyway. I think all of us did that so be it, right? If you want to do work in schools and you want to try to make changes, then you just have to know that your research designs are not going to be neat. So this is what the model of support for professional development providers looks like. This is where we ended up. It's not where we, I mean, it's kind of basically what we started with, but we started it as a vague idea, and by the end we had, developed it into something that we could say, okay, this is our model. So we start with the Summer Leadership Academy, in which people start to think about, so what does it mean to be a professional development leader? One of the tasks during the summer is to pick the problems, and then another task in the summer is what Pam Grossman and colleagues are calling successive approximations. So we start by doing a mini cycle with them and modeling it for them and talking about what we're doing, and then we had them rehearse the different aspects. So they weren't able to rehearse with video from, that they would actually be using, but at least that they could take a segment of video and they could rehearse planning a discussion around it and then leading the discussion around it. And then before each workshop, or before, realistically now, it's like 3 times during the semester. Once after they've taught the problem, before their teachers have, we meet with them so that we can work with them on doing mathematics with teachers and helping teachers plan. Then after their teachers, or at least some of their teachers, have taught the lesson, we bring them back and work with video, have them choose video, plan discussions so that they can do their second workshop. And then we bring them back again so that they pick more video and again do another cycle. What I've really learned in San Francisco is that typically here they end up using only video of their own classrooms. And by here they're bringing in video from other classrooms, and part of that is just teachers don't teach it necessarily as soon as we had hoped that they might. And also the leaders, at least initially, are more comfortable using video of their own classrooms, and they're more comfortable that they can share. It's less risky for them to share their own video than for other teachers to share. So that's another thing that we learned, that if we were to update a facilitator guide, that'll probably be an explicit suggestion. So we use the mathematical knowledge for teaching test that also was developed at Michigan by Deborah Ball, Heather Hill, and colleagues. Our sample was small. We had all of the teachers in each school take the MKT. Now, some of you have probably already figured out that between the pre-test and the post-test, for some schools there was a 2-year period, for other schools there was a 1-year period. We collapsed them because that's what we could do. And what we found though is that, and what we did was look at percent correct. So we did paired t-test, which is not the most robust of statistical tests. We were supposed to have a control group or a comparison group of teachers. Those data kind of never came into us. So we did paired t-test, and we found that there were significant changes, significant growth in MKT for all of the teachers and for the regular teachers, not for the teacher leaders, but that's because the sample was so small, right? So the sample was small and the range was large. So the magnitude of the change was greater. Just with 8 of them, it wasn't statistically significant. Okay? But we were actually pleased that we could see statistically significant results with that small of a sample. So the next analysis that we did was looking at implementation of the problem-solving cycle. To what extent did the teacher leaders enact it with integrity to its key features, and what features seemed to be, did they enact particularly well, and what features did they have difficulty with. We started actually with a rating system, the Professional Development Observation Scale that was developed at Horizon Incorporated. It was developed for the early Eisenhower math science studies. It's a rating scale, so you rate the professional development along a number of different dimensions. And in their case, they were looking to see if the ratings were statistically, were predictive of student achievement. We chose, and it's a pretty gross measure in some ways because it's a rating scale. We chose to use that as a starting point because really there's so little known about this, what it is that professional development, that teacher educators or professional development leaders do. And so Ruhama even, this is a quote from her work. She's one of the early people who did some work in this area. And again, the analytic framework that we used was based on the PDOP. We looked at 5 different areas: workshop culture, workshop design and structure, which has to do with did they structure them, did they design them and structure them in ways that use time effectively, depth of knowledge of mathematics, depth of knowledge of instructional practices and student thinking, and for each one of those there's a number of indicators, and I'm going to show you some of the patterns that we saw in a minute. So we took the PDOP and then we modified it to take into account the focus of our project. We added some specific facilitation practices that were based on Mary K. Stein and Peg Smith's notion of 5 practices. They talk about 5 practices for leading discussions of mathematics, for teachers leading discussions of mathematics for students. Those practices fit equally well for facilitators using those practices to facilitate discussions with teachers. So we borrowed some of that. And we also looked to Heather Hill, Deborah Ball for more specific indicators of mathematical knowledge for teaching. And then we also added some indicators about the video, so the selection and the use of video. This is the problem we used. So basically, I'll let you read it. So basically, it's a problem that can be solved either with miles or with fuel. It's a problem that can be solved using fractions or using decimals. Again, this is ratio and proportion. There's not as many ways to extend it. That seems to be typical of ratio and proportion as opposed to algebraic reasoning. When I say that this is the problem we used, this was the 4th problem. So this was the problem in the 4th cycle. The data that I'm going to share with you today are just the data from that cycle. We analyzed all of the video from the 1st cycle and the last cycle. This is kind of where they ended up. And the other thing, so we analyzed, we looked at all of the indicators. I guess I should say a word about the way that we did the analysis is that I was working with 2 graduate students. The 3 of us coded independently, or rated independently, came back and shared our ratings, kind of figured out the scale and modified it. And when we were all on the same page, I stopped doing the work and the 2 of them coded all of them. And rather than trying to look at reliability, we chose to work on consensus. So they got together and resolved their differences. And it turns out that they were, if we had done formal reliability checks, they were almost always in agreement. So what this represents is looking across across all of the workshops conducted by one facilitator, so this is all of the facilitators, one group, Joe and Kim worked in as a team. And this is, we looked for patterns within each of the broad areas, and we selected indicators that are representative of those patterns. The first three are people who were our 2-year facilitators, and the last 5 are students. So one of the things that we felt good about is basically in terms of developing a climate of respect and a supportive community, they scored really highly. It's a 5-point rating scale. They had more difficulty with participants willing to share ideas and take intellectual risks, and we think that's just because that takes a little bit longer before a community is willing to do that. And this is Joe and Kim, the co-facilitators, and what they said about it. So it's clear that they're being very intentional about developing community. I think I'm going to skip this one and go on to. So this is specialized content knowledge. This is only ratings from the first workshop because it's the first workshop where they really dig into the mathematics, and the way that the PDUP was designed. The instructions are only if a major portion of the time and if a major focus of the workshop is on the mathematics or the science, do you code that workshop? Otherwise, you don't code it. And the same is going to be true for knowledge of content in students and knowledge of content in teaching. So given our focus on representations and solution strategies, we had several that dealt explicitly with solution strategies and several that dealt specifically with representations. So again, what do you notice? There's lots of patterns to maybe notice.
Well, they can discuss the representations, but they don't know the relationship among the representations. I won't say don't know it. They don't discuss
The
it.
discussions are stronger around what are the representations. And again, this is after teachers have solved the problem, right? So teachers are good at discussing all of the representations and putting them on the table. And the discussion is not as rich around sort of what are the relationships among the representations, what are the constraints and affordances of each of the representations. So this just kind of highlights that. So they can generate and they can put on the table, but the analysis looks weaker. Another thing that starts to show here is that there's real individual differences among the facilitation teams or the facilitators. So one of the things we learned, I mean, Kim and Joe were really strong facilitators. They're also, we learned that there's some real advantages to co-facilitation. And actually the work that I'm doing now in San Francisco, we strongly recommended co-facilitation. Carol was the only facilitator who was not the chair of the math department. So she had a little bit harder time getting buy-in from the teachers. And you can see so her facilitation doesn't look as strong. And then Jordan, this is a really interesting one. He looked a lot stronger his first year than his second year, and that was the group of teachers changed from year 1 to year 2, and he just had a really hard time getting that group of teachers to work together. So, you know, it's interesting for us to kind of look more closely at these and try to figure out, so what are some of the things that we're really learning about facilitation through this? So what you can see here is that they were, again, very intentional about getting people to use and put on the table and discuss different solution strategies. And Kim and Joe actually did tell the people, so they had a 2-hour block to do the problem instead of a 1-hour block. So they had everybody solve it one way first, and then solve it the other way second, so that they could, and even so, their discussion of relationship between them wasn't as strong as their discussion of each of the requisite solution strategies separately. Okay, I know this is hard to read, but I wanted to pack it all into one table so that you could start to look at some of the patterns. So this is their pedagogical content knowledge. So the first 2 are about the video clips that they select. The next 3 are about knowledge of content and students, and the last 3 are about knowledge of content and teaching. Same question. What do you notice?
Analysis is their strongest strand.
Is that, Amber?
Analysis isn't their strongest strand.
Analysis is not their strongest strand. Where they're strongest is the video. And actually, this was something that we were really glad to see, because when we started talking with colleagues about this professional development, a number of people were pretty skeptical, you know, because teachers aren't used to working with video. They're not used to working with video of their own teaching. Are the facilitators, are the math teachers really going to be able to pick video clips that have the features that will likely lead to rich discussions? And we did a lot of work with them up front about how to do that. We spent a lot of time with them in professional development support meetings to help them select video, but we didn't select it for them. They really did the selection. So we were really pleased to see that at least we can say, yes, this is a sustainable type of professional development, in that you do get good video this way. That was another concern, you know, comparing it to Nanette Segal's. Are we going to? No, we don't have the quality of video that she has, certainly, but the video is high enough quality to be usable in professional development, and the math leaders are able to select the video. And it's much more difficult for them to then facilitate discussions that keep a deep level of analysis. So, Mandy, who was one of the strongest, who actually, if you look back, she actually was able to maintain a high level of discussion. Some background from her too. I mean, she was like a 3rd or 4th year teacher. She had gotten her teaching certification at Michigan State. She happened to work with John Starr, who is a person who's very well regarded as a secondary math educator who clearly pushes for this kind of teaching. So in a sense, and so she actually, when she came to us as a math leader, she got it. I mean, she already kind of taught that way, and she had a sense of how to help other teachers teach that way. And again, Joe and Kim were strong, but you can see here that she also had a sense of how to go about preparing for this kind of a discussion. So she really thought about the questions in advance. And then Jordan and Carol, the two people who were sort of consistently not as strong, both of them actually were pretty explicit about, yeah, we know we need more help with this. We know we need some more work figuring this out. I thought this was a really interesting sort of metacognitive awareness on his part. So overall, features that were more easily enacted, again, climate of respect and trust, the design and structure of workshops, which we didn't look at. This was a really nice one for us because they were so limited in time. And they felt rushed for time, but yet it was really clear that they used the time that they had well. And then the selection of video clips. And features that were more difficult to enact. So we've already talked about the features. One of the things that was interesting to us was to go back to the literature on classrooms. And, you know, intuitively, we kind of know, yes, this is the same kind of thing that you would see in classrooms with teaching. Elham Kasemi, for her dissertation, did a study of elementary classrooms, and she talks about this notion of low press and high press exchanges. And she talks about low press exchanges in a classroom would look like solving open-ended problems in groups and sharing solution strategies. High press exchanges would be collaboratively examining relationships among multiple strategies using mathematical argumentation to arrive at shared understanding. So, I mean, the language is almost identical. And we, you know, so we found that afterwards and we thought, okay, that's, clearly it's not surprising, but it's also nice to know that this is a pretty robust finding. And they also talked about that for teachers in elementary classrooms, in order to foster high press exchanges, you need a deeper understanding of the mathematics than for the low press exchanges. And we would argue that for facilitators it's the same thing, but it's not just mathematical knowledge for teaching, it's mathematical knowledge for professional development. And then Smith and Stein, again, their 5 practices, they talk about the notion of orchestrating discussions as skillful improvisation. And one of the graduate students who works with me is actually an improvisational actor, so I've talked with her a lot about improvisational acting and the kind of preparation that they do. And the kind of preparation that they do for improv is not all that different than the kind of preparation we would like teachers to do and that we would like the PD facilitators to do. So we now spend a lot more time with them looking at a video clip and asking them questions like, okay, what do you want the teachers to notice in this video? What kinds of questions might you ask? Where do you think the discussion might go? If it goes in these directions, what kind of prompts might you have in your back pocket? And we're finding, I guess what I would say that we're seeing in San Francisco is that I haven't looked at the video yet of their workshops, but I know from our meetings with them that they're starting to really understand what that means and what that looks like. And we can see in their rehearsals, like in the rehearsals that they did the first time, they had great guiding questions and their video were good, and they really didn't have any sort of back pocket questions. And by now, after they've done one round of facilitation, in the workshops that we've done with them more recently, we can really see them like working and asking each other, what do we want them to notice? Okay, and what kinds of questions can we have if the conversation falls flat? And again, so and I know that I think Anne was mentioning Bass is working on this notion of mathematical knowledge for teacher education. I think, somebody was mentioning that today.
I was mentioning that there was a discussion group on it.
Okay, there's a discussion group on it at ICME, and I think he has been working on that notion. He hasn't, I haven't read about it yet, I've heard him talk about it, and we came, I mean, so the phrase we use is mathematical knowledge for professional development. That there's some additional knowledge that you need of the mathematics and of student reasoning and instructional practice in order to be able to run professional development. You can see that I'm not articulating it very well. We're having a hard time articulating exactly what that is. It's like we know it when we see it, and we're working on trying to articulate it. And another part of this MKPD, we think, is really this notion of establishing and maintaining a professional learning community. LCK so far is the best acronym we've come up with, and we don't really like it. But and just one quick example of that is the notion of a teacher task, which is something that a number of, like, the people we first heard it from were Judy Mummy and Kathy Carroll, who do professional development for leaders, and Rebecca Elham and Elham Kazmi, who are doing research with them. They talk about teacher task, and when Judy was on our advisory board in Colorado, and she said, well, you know, we've been working on this notion of teacher tasks, and here's a student task, here's the teacher task that we developed. So part of mathematical knowledge for professional development is being able to develop these teacher tasks that are going to help teachers to think about how to prepare to teach the mathematics. Questions? So just really quickly what our ongoing work is. 3 sets of analyses are currently underway. Instructional practices, so Karen Kellner and Jennifer Jacobson, they have a paper that's going to be in ABRA this year. We're just putting it together. They've now analyzed all of the instructional practices from the first cycle. And are looking and are trying to ask the question, so are we seeing changes in instructional practices among the teachers? And again, the answer is yes, and it's complex. And they just sent me the paper, so I can't even tell you about all of the complexity. Student outcomes, we finally have, this is now 2 years later, we finally have the student data. So we're now in the process of running the analyses to see if there's a relationship to student outcomes. And facilitation moves, one of the things that we were dissatisfied about with the professional development, with the PDOP, is that it is it's very general, and it doesn't help us really unpack what those facilitation moves look like and what happens with particular kinds of facilitation moves. So my group at Stanford is now using a video analysis program called Studio Code, where we're actually coding instances of this. We're coding every facilitation move, which is as far as we've gotten now. So we have a list of 11 different facilitation moves, and then different aspects of the mathematics and the student thinking and the pedagogy. And then the next thing we're going to do is analyze the discussions that happen, and then we're going to try to look at relationships so that we can really understand at a much more micro level. Is there a relationship? You know, to what extent are teachers using this facilitation moves that dig more deeply, and what are the facilitation moves that lead to a deeper, richer conversations? And we already know that there's some interesting individual differences. We started with Kim and Joe, and one of the things that's we quickly became aware of as we were driving ourselves crazy is that in 1 hour of facilitation, they had 90 different facilitation moves. So, and the proportion of time they're talking is not great. So they're just quick moves and questions. And we know that some of the others, that pattern's going to look a lot different. So we're really excited and curious about it. And then the other work is the work that we're doing in San Francisco. So, the work in Colorado was taken up by the leader of the middle school professional development leader, which was very cool. And she now has incorporated the problem-solving cycle into their district-level professional development. It, of course, does not look exactly the same, but we would say that the key principles, shared work on mathematical problems and use of video based on the teaching of those problems has remained at the core of it. And then we're working now in San Francisco, which proves to be much more challenging. It's a much more complex school district, and in one of the classrooms, I had to get permission slips in 8 different languages, and parent permission slips in 8 languages. So we have a much greater focus on English learners. So that's it. Questions, comments?
We might need to let people move follow-up discussion to the conference room, because I'm betting there's a class in here at
Okay.
7 o'clock. And I know some folks have places they need to get to. So I'm not sure what time you guys are planning to go to dinner, but is there time?
6:30.
6:30. Is there time for at least a few minutes?
Yeah, it's
If
only
people
fun,
want to
yeah.
ask some questions, they can
Yeah, I think this was
Reconvene.
scheduled to go at least until 5.
till 4:30.
Okay.
Yeah.
Oh.
But I used to have, like,
Oh, so what I thought it said from 3:30, okay. Sorry about that. I wouldn't have run on so long. I really thought.
Sorry, I interrupted. Yeah, I think I sent all the
Strong work.
All right.